Okay, so let's have the next one, which is what is most nearly the resulting pressure when 400 grams of air at 103.6 kilopascal and 93 Celsius is heated at a constant volume to 427 degrees Celsius. So you have to take note of that constant volume. So if that is a constant volume, we can already consider that this is a Gay-Lussac's law, right? Because constant volume, therefore the volume is not changing. The volume remains the same. So volume is constant. Okay. Now, what are the givens? So we have a mass of 400 grams. Remember, this is air, and then we have a pressure of 103.6 kilopascal. What else? We have two temperatures. So we have T1 and T2, right? So T1 is 93 degrees and T2 and is equal to 427 degrees. Okay, so we have two temperatures, T1 and T2. So remember that it's not yet in absolute temperature, so we have to convert those um in Kelvin. Okay, so what is required? We are required to find the resulting pressure, right? So we are required to find what? Of course, P2. Okay, P2. So it should be in kilopascal also because P1 is in kilopascal. So what is the solution? Of course, writing down again the general formula, which is PV is equal to nRT, and then consider which parameters are constant. Okay, so which one? It should be V is constant, right? And N also constant, and R is also constant. So we are only dealing with P and T. Okay, so cross multiplying all the constants and non-constants to separate them, of course, so it will become P over T is equal to N R all over V. And NR all over V is constant, right? So we'll just make it equal to C. Therefore, you'll have here P1 over T1 is equal to P2 all over T2. And then substitute all the givens that we have. Okay. So which one? We have P1 103.6, right? 103.6 kilopascal all over what's the given for T1? That is 93. Okay, so you have to convert it into Kelvin. So 93 plus 273 to make it in absolute temperature, all equal to. So P2 is the one that we're looking for. That is the required, and the temperature 2 is 427 plus 273 again, right? And then using your calcu to solve for this one, so the final answer that you'll have is approximately equal to 198.1421, of course, in kilo Pascal. Okay, that's it. And let's have the next one. Okay, so let's have the fifth one, the number five, the valve between a 9 liters tank containing gas at 5 atmosphere and a 6-liter tank containing gas at 10 atmosphere is opened. So what is the equilibrium pressure obtained in the two tanks at constant temperature? Assume ideal gas behavior. Okay, so we have here two tanks, right? And it is connected by a valve, and then the valve is open. So what happens here? Okay, so let's put down all the givens that we have first. So we have the first tank, which is we have V1 is equal to 9 liters, and we have a pressure also here, which is 5 atmosphere. So that is P1. For the second tank, we have V2 is equal to 6 liters, and we have, of course, P2 is equal to 10 atmosphere. So what do we do from here? So as you can see, there's a valve opening. Okay, so the valve will be opened. So therefore, whatever is inside, they will be combined, of course. But we have to consider that is in constant temperature. Okay, so if this is a constant temperature, so we can already say that this is Boyle's law. Now we will be using what we call by mole balancing, because what we do here is, since uh, the whatever gas is inside, they will be combined. Okay, of course the number of moles will be added. Okay, can be additive. So the number of moles in two tanks will be additive. So the equation that we'll be having here is And the method that we can use here is by mole balancing, of course. Okay, so considering the givens, right? So we can have here N1 plus N2 is equal to N. N1 and N2 are the moles, number of moles in the respective tanks, of course, right? And N1 is the first tank, N2 is the second tank. And let's say that N is the total number of moles. So going back to the ideal gas law, we have PV is equal to nRT, right? And what is N? Okay, so we have to isolate N. So isolating it, we will have N is equal to PV all over RT. Okay, so writing this or substituting this to our equation, but of course adding the subscript. So we have P1 V1 all over. So of course R and T won't have any subscripts because those are constants, right? R is constant, temperature is also constant, right? So plus we have P2 V2 all over RT again and all equal to, of course, the total pressure and total volume all over RT again. So as you can see, we have a common RT, so we can cancel those out. Use. So we have P1 plus V1, P1 V1 plus P2 V2 equal to PV, which is the total pressure and volume. So we can have now we can just substitute the values that we have here. So what is P1 and V1? So we have 5, right? 5 atmosphere and 9 liters plus, which is P2 V2, that's 10 and 6. We have 10 and 6 of, okay, 6 equal to, now what is the total pressure is the one that we are looking for. So the P is the one that we are looking for, so we'll just leave it at P. And of course the volume, since they are being combined, of course we can just add the volume, so it will become 9 plus 6. Okay, so 9 plus 6. And then, of course, using your calculator, the one that you will be getting here is around 7 atmosphere. That's it. And let's have the next topic.